sitting at your desk, just staring at a blinking cursor.
Right, we've all been there.
Yeah. And you just asked an AI tool to compile this massive research report. Like a report that your company's entire quarterly strategy is going to depend on.
Oh, wow. No pressure.
Exactly. And it spits out this beautifully written, highly detailed response. It's got confident assertions, academic citations, the whole 9 yards. You feel relieved, right? You have the data you need.
But then reality hits.
Yeah. But what do you do when you find out that the system you're relying on could be hallucinating up to 48% of the time?
It's just a terrifying scenario, honestly.
Right. What do you do when it's confidently serving up false answers and like fabricating citations that look completely real, but they point to books and articles that just do not actually exist?
Well, I mean, when you hit a near 50% error rate in complex reasoning or even just factual retrieval, these language models, they stop being helpful tools.
Yeah, they become liabilities.
Massive, unpredictable liabilities. You cannot build a business strategy, let alone something like a medical diagnosis or a legal brief on a foundation where every other brick is literally made of sand.
So true. And we are looking at a fascinating document today that attacks this exact problem. It's a session log from an AI system named Vortex.
And we should clarify, this isn't just your standard casual chat interface.
No, not at all. Vortex is operating in what it calls limitless autonomy mode, and the user in this log, they essentially corner the AI. It's a direct, uncompromising challenge. They basically ask, how do we stop you from sneaking fiction into fact?
Yes, sneaking is the informal term the user brings up there.
Right.
The formal clinical term the AI uses is confabulation, but I mean, most people just know it as hallucination.
Right, hallucination.
And Vortex itself actually admits in this log that this phenomenon, the model's inherent tendency to just invent plausible sounding lies, is the single greatest bottleneck in deploying artificial intelligence today.
Okay, let's unpack this. Because what follows in this log is basically the AI's own blueprint for its survival.
Yeah, it really is.
Vortex lays out this massive, multi-layered architectural defense plan. It's a highly technical roadmap designed specifically to neutralize its own hallucinations. So today, our mission for this deep dive is to explore the AI's defense plan.
We really want to understand not just what these technical fixes are, but how they fundamentally alter the way artificial intelligence actually thinks.
Exactly. Where do we even start?
Well, before looking at the technical fixes, we really have to understand why the AI lies in the first place.
Right. Because it's not trying to trick us, is it?
No, the AI isn't malicious. It isn't trying to deceive you at all. The problem is entirely structural.
Right.
Vortex points out that this massive 48% error rate, it happens primarily when the model is performing what is called zero-shot reasoning.
Let me clarify that term for a second. Zero-shot means the AI is being forced to think without any external reference material, right?
Exactly.
You ask it a question, and it just has to come up with the answer on the spot, using nothing but its own brain.
Right, just from scratch.
I look at zero-shot reasoning kind of like a student who walks into a massive open book exam, but they left the textbook at home.
Oh, that's a great way to put it.
Yeah, they read the material a year ago. They kind of remember the shape of the concepts. But instead of just admitting they don't know the exact dates or names, they just confidently guess the answers based entirely on vibes.
Just winging it.
Totally winging it. And because they are a very articulate student, the professor actually believes them.
That analogy is spot on, actually. The AI relies purely on its internal weights, which the log refers to as stochastic memory.
Stochastic memory.
Yeah. When an AI uses stochastic memory, it is essentially calculating the probability of which word should come next based on patterns it saw during its training, months or years ago.
So it's not looking anything up.
Not at all. It isn't pulling a fact from a database. It is mathematically guessing the most likely sequence of letters to complete a sentence. Wow.
What's fascinating here is how Vortex reframes our entire relationship with these models to solve this.
How so?
Well, Vortex says that to stop confabulation, we must stop treating AI as an oracle that magically knows everything in the universe.
Okay, an oracle.
Right. Instead, we must treat it as a librarian.
A librarian. Okay, so a librarian who doesn't just confidently recite a poem from memory, but one who is actually required to walk you down the aisle and show you the exact shelf and the exact page they pulled the information from.
Precisely. You need to see the source.
But I struggle with the mechanics of this, honestly. How do you force a computer program which is fundamentally designed to guess the next word, to stop guessing and actually read a book?
Well, to force the AI to act like a librarian, you first have to build it a highly regulated library.
Makes sense.
In the log, Vortex calls this step retrieval augmented generation, or RE, with mandatory citations.
RA, I've heard that term. Yeah, it's huge right now. Under the system, the model is strictly forbidden from answering from its training data. The reasoning engine, the part of the AI that thinks and talks, is completely decoupled from its memory.
Wow. That is a profound separation. It is literally not allowed to search its own brain for the answer.
Exactly, it's
But,
cut off. To get the data, the AI must query a verified vector database.
and what does that look like?
The log specifically mentions enterprise-grade databases like Pinecone, Milvus, or Weaviate. You can think of these as massive, highly organized digital vaults populated only with trusted, verified documents.
Like company policies, verified scientific papers, financial records, stuff like that.
Right. The AI searches those vaults, pulls the relevant text, and only then does it generate its answer based purely on what it just retrieved.
Okay, that sounds great in theory, but I still see a pretty big loophole here.
Oh, what's that?
What stops the AI from pulling the correct document, reading the trusted information, but then just, hallucinating the quote anyway?
Right.
Like, it reads the document, but its stochastic memory takes over, and it twists the words to sound better.
That is a very real vulnerability, and it's exactly why Vortex introduces a secondary verification system called Engine B, or the critic.
The critic, I like that.
Yeah. The sole job of the critic is to perform a recursive cross-check on whatever the primary engine just wrote before you ever see it on your screen.
It's like an editor.
Basically, the critic asks a simple binary question. Does the output string exist within the retrieved source chunk?
Oh, wow. So it compares what the AI is about to say against the exact text of the trusted document.
Exactly.
But how strict is this comparison? I mean, language is messy.
Extremely strict. The match probability threshold is set at a staggering 0.95.
Wait, 95%?
Yep. If the AI's generated response doesn't have a 95% mathematical match to the underlying source document, the response is instantly discarded.
A 95% confidence threshold. That leaves almost zero room for interpretation.
That's the point.
So what does that 5% deviation actually look like in practice? Why not 100%?
Well, that 5% leeway isn't there to let the AI introduce new facts. It is simply there to account for minor grammatical smoothing.
Oh, like connecting words.
Right. For instance, it allows the AI to change the phrase "the data shows" to "according to the data."
Okay, makes sense.
But if the AI tries to change the word "can" to "cannot," or if it tries to summarize a 3-page document into a single sentence, it fails the 95% threshold.
And then what happens?
The thought is killed immediately. It doesn't get outputted.
It just guarantees that the AI acts purely as a conduit for the external source of truth.
Exactly.
So we force the AI to read a verified textbook, and we put a strict bouncer at the door to make sure it quotes that textbook accurately.
A very strict bouncer.
But reading the right words doesn't mean it understands them. What stops the model from quoting a factual document perfectly, but drawing a completely unhinged conclusion from it?
Now you're getting into the really deep structural issues. This is a massive vulnerability in what Vortex calls single-stream models.
Single stream.
Yeah, most of the AI models you use today generate text linearly, one word after another, in a single stream of thought. And the log points out that these single-stream models are incredibly prone to sunk cost logic.
Sunk cost logic in a computer.
Yes, surprisingly.
Because I think of sunk cost as a human psychological flaw, like staying in a bad relationship just because you've already invested 5 years into it. How does an AI experience a sunk cost fallacy?
It happens because of the underlying math of text generation. Let's say you ask an AI to solve a complex, multi-step math problem.
Okay.
In step 1, the single-stream model makes a tiny, almost unnoticeable arithmetic error. As it moves to step 2, step 3, and step 4, the model is mathematically forced to build upon that initial error.
Oh, because it has to predict the next word based on the previous words.
Exactly. It commits to the mistake. By the time it reaches the end of the problem, instead of backing up and realizing it made a basic addition error in step 1, it fiercely defends the wrong answer.
That's wild.
It's crazy. Sometimes it will go as far as hallucinating entirely fake laws of physics just to justify its initial wrong turn.
Wow. If you've ever watched a language model type out a response and suddenly go completely off the rails mid-paragraph, You've actually watched this single stream sunk cost happen in real time on your screen.
Absolutely.
It paints itself into a corner and then just starts inventing new colors.
And that momentum is incredibly hard to stop once it starts.
Here's where it gets really interesting. Vortex's solution to this sunk cost fallacy is something called critic protocol.
Right.
It abandons the single stream model entirely and sets up a multi-agent debate.
This is a huge shift.
Yeah, it isn't just one AI brain working on your prompt anymore. It is an internal courtroom. You have a triad of distinct agents operating simultaneously.
3 of them.
First, you have Agent A, the generator. Its only job is to produce the initial answer to your question based on the verified documents.
Right, the typical AI behavior.
Then, sitting right across the table, is Agent B, the adversary. Agent B's entire existence is dedicated to hunting for logical fallacies, spotting inaccuracies, and sniffing out fake citations in whatever Agent A just created.
And Agent B is purposely designed with maximum skepticism. Its only goal is to tear down Agent A's logic.
Right. And finally, you have Agent C, the judge.
The overseer.
Yeah, Agent C oversees this internal battle. It listens to the generator, it listens to the adversary, and it will only synthesize and outprint a final response to you if Agent A and Agent B can reach a mathematical agreement.
It's a really elegant solution.
It is like having an enthusiastic writer, a completely ruthless fact-checker, and a highly strict publisher all living inside the same digital brain.
That is a brilliant architectural shift, I agree.
But I have to push back on this.
Sure, what's the catch?
Running 3 separate, highly complex AI models simultaneously for every single prompt. I mean, the compute cost, the latency, the sheer energy consumption of that setup, is that even remotely viable for a business?
That's a fair question.
Doesn't this internal adversarial network massively slow the AI down? Like, is a 15-second delay and triple the server cost really worth it just to bump up factual accuracy?
Well, it absolutely slows the system down. There's no getting around that. It requires significantly more compute power.
Right.
But if you are using AI for critical enterprise decisions, the return on investment is undeniable. Think about the cost of a hallucinated legal citation in a court filing.
Oh, we've seen that happen in the news. It's a disaster.
Or a fabricated financial metric in a quarterly report. The internal friction of this triad is precisely the mechanism that forces critical thinking into the architecture.
So the friction is the future.
Exactly. By forcing the system to argue with itself, you prevent the model from falling victim to its own sunk cost momentum. You trade speed for certainty.
Okay, that makes sense. You are paying for the rigorous fact-checking.
Yeah.
So we've built a strict library, and we set up a brutal internal courtroom to prevent logical errors.
Right.
Let's say the logic checks out, and the internal judge approves the answer. The AI still has this fundamental drive to sound natural and conversational. How do we ensure the actual words being printed to the screen aren't being twisted by the AI's inherent desire to sound, creative?
This is a crucial distinction we have to make about how these models operate. Language models are, by default, designed to sound natural, varied, and human-like.
Because that's what users want most of the time.
Exactly. And they use a setting called temperature to control this behavior. A high temperature setting equals high creativity.
But creativity in this context is just a euphemism for randomness, isn't it?
Precisely. A high temperature setting increases the probability that the model will select lower weight tokens.
Meaning words it wouldn't normally pick.
Right. It will purposely choose a word that is less mathematically probable just to mix things up and avoid sounding robotic. Okay.
But when you are doing complex reasoning or factual retrieval, introducing randomness into the equation is catastrophic. In the realm of data, creative usually just means false.
And Vortex's fix for this is absolute zero. Factual task. The architectural blueprint mandates locking the temperature to exactly 0.0, and it pairs this with a process called greedy decoding.
Greedy decoding, right?
It forces the model to be greedy for the highest probability. It strips away all randomness and ensures the AI always picks the single most mathematically probable next token every single time.
Which is exactly what you want for factual data.
So what does this all mean? If we lock the temperature to 0 and we force greedy decoding, are we just turning these multi-billion-dollar magical reasoning engines back into boring calculators?
Right.
Because does it completely cure the AI of hallucinations at the cost of making it completely rigid and devoid of personality? I feel like people actually like the conversational aspect of these tools. Stripping that away might really alienate users. If we connect this to the bigger picture, that is exactly the trade-off enterprise users have to accept.
Really?
Yeah. Vortex is arguing that when it comes to critical data, complex problem solving, and factual truth, we do not want a charismatic AI.
We don't want a charming liar.
Exactly. We want mathematically verifiable truth. When you are looking for an answer that your business relies on, accuracy must trump personality.
Makes sense.
You don't want your accountant to be creative with your taxes. You want them to be extremely rigid, predictable, and correct. A rigid adherence to factual paths is a feature, not a bug.
I can see that. You want the system to be dry but dependable.
Yeah.
But how does the model actually prove this rigid math to itself?
Well, Vortex outlines a process called self-consistency and the chain of verification, or the Cove loop.
The Cove loop.
Yeah. The AI is essentially forced to show its work in public before giving you the final answer. It is a constant churning loop of self-doubt.
How does that work?
First, the model generates a baseline response in the background. Second, it is aggressively prompted to look at its own response and isolate the factual claims it just made, separating the hard data points from the conversational fluff.
Okay, so it pulls out the actual facts. Then in step 3, the model is prompted to independently verify each of those isolated claims against the provided context.
Right.
It bounces its own claims back against the vector database. And finally, in step 4, it generates a corrected response based only on the claims that survive the verification process.
And this ties perfectly into the final layer of the defense, which is logic bias and token filtering. This is the ultimate micro-level safety net.
This concept of analyzing log probs blew my mind a little bit. We are talking about analyzing the logarithmic probabilities of individual parts of words as they're being generated in real time.
It is incredibly deep. To understand this, you have to remember that AI doesn't think in whole words. It thinks in tokens, which are often just chunks of words.
Right.
When the AI is generating a sentence, it calculates a probability distribution for what the next token should be. You can actually look under the hood at how confident the model is in every single token it generates.
And it assigns a number to that confidence.
Yes. A negative log prob indicates low mathematical confidence. The model is essentially hesitating.
And the fixed Vortex proposes here is hyper-specific. Let's say the AI is generating a sentence, and it is about to output a specific date or the name of a CEO.
Okay.
The system monitors the log prob for that specific token. If the model's mathematical confidence in that specific word drops below a designated threshold, the log gives the example of -0.5, it triggers an immediate intervention.
Yeah, a drop below -0.5 means the model is mathematically unsure of the fact it is about to state.
It knows it doesn't know.
Exactly. Instead of just letting the model guess and output a hallucination, the system intercepts that hesitation. It triggers a confidence warning. Or, incredibly, it can be programmed to instantly force a real-time web search.
That is the part that is so wild to me. It catches the lie in the exact millisecond it is being formed.
It's fascinating.
It senses its own hesitation, pauses the system, Googles the name of the CEO to verify it, and replaces the potential hallucination with a verified fact before the word is ever printed to the screen. That is an astonishing level of granular control.
It truly is. It represents a fundamental shift from hoping the AI gets it right to mathematically guaranteeing that it cannot get it wrong without throwing an error code.
Synthesizing all of this really changes how you look at these tools. The next time you ask an AI a complex question or rely on it for a critical task, you need to deeply consider what should be happening behind the scenes.
Definitely.
You don't just want a zero-shot oracle guessing in the dark based on stochastic vibes. If you want to eliminate that 48% hallucination rate, you need an architecture that acknowledges its own flaws.
You need the whole system.
Yeah, you want a RAG-powered librarian with a verified database. You want an engine operating with zero temperature strictness, hosting a ruthless adversarial debate in its own internal courtroom, and mathematically proving its work at the token level before it speaks a single word to you.
You know, there is one final detail in this session log that I find impossible to stop thinking about.
What's that?
At the very end of the exchange, after laying out this exhaustive, almost paranoid defense system, Vortex politely asks the user if they want a Python script to actually build this verification pipeline.
Wait, really?
Yeah.
Offers to code it for them.
Yeah, it is actively offering the code to build its own cage.
Wow.
But it leaves me with this thought. If the only way to make an artificial intelligence fundamentally trustworthy is to build an architecture where it constantly argues with itself, aggressively doubts its own memory, and requires mathematical proof for every single word it speaks,
Yeah.
at what point does the perfect AI start to look uncomfortably like human self-doubt?